So in 4.3, we're going to have several sections. We're going to have section A, B, C, D, and all that. Today, we're going to focus on parabolas. And again, the conic section, which is 4.3, we're going to deal with, cross sections of these conics, and we're going to see that the cross sections give us different shapes. They give us circles. They give us ellipses if they come in at an angle. They're going to give us parabolas, which is what we're going to talk about today, and they're going to give us hyperbolas if the cross section goes straight down. So once again, we're going to talk about those cross sections in further detail, but right now we're just going to focus on various parabolas. Now, up until now, we've always done the basic parabola, which has been an x squared equation. And all we really did was we asked you for the vertex, we asked you for the axis of symmetry that kind of went through the vertex, right? Axis of symmetry. And then we would pick a point on the left, we would mirror, or on the right, we would mirror it to the left, and we'd kind of draw our parabola. And that's the extent of what we did. Now we're going to start talking about more features, and we're also going to deal with parabolas where the y is squared. The parabolas that open up and down are parabolas that are x squared. And again, we'll talk about that in subsequent slides. But basically, a parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called a focus. The focus is not on the directrix. So again, let's kind of look at what we're talking about. If I take any point on my parabola, like here, right? This point is d1 units away from this point called the focus. It's exactly d1 units away from this line called the directrix. So this point right here is equidistant from the focus and the directrix. I pick a second point, this point. Well, this point is equidistant from the focus and the directrix. Whatever this length is, let's say it's 10, this bottom length D2 is also going to be 10, and so on and so forth. I can pick a third point, and I know that this point is going to be not like that, sorry. It's going to be D3 units away from the focus, and it's going to be D3 units away from the directrix. This line is going to be congruent with that line. And so again, the parabola ends up being created by these set of points that are all equidistant. And just like all those points are equidistant from the focus and the directrix, so is the vertex. The vertex is going to be equidistant from the focus. Whatever this length is, it's going to be the same length to this directrix. Okay. Now the difference is all these other lengths are called D1, D2, D3, whatever. This length, we give it a name and we call it P. So P is the distance from the vertex to the focus and the directrix, and we'll talk about that P value later, okay? Now the midpoint between the focus and the directrix, that's going to be your vertex. Your the line that passes through the focus and crosses the directrix perpendicular is going to be your axis of symmetry, but you don't need to know that. Okay, so let's start out with your standard form for the equation of a parabola, all right, with a vertex of 0, 0. So we're going to start easy. So remember that if I had done your parabola, your standard parabola where x was squared, you had a formula that basically said that y equals, and you did a times x minus h squared plus k, right? And let's just say that the vertex was 0, 0, right? So your h was 0 and your k was 0, right? Well, notice you would have y equals a times x squared, and it would be plus 0, so the 0 would be rooted out, right? Well, what we're going to do is we're going to rearrange this formula a little bit, okay? First of all, we're going to move the a to the other side. So we're either going to multiply by 1 over a, right? We're going to do 1 over a and 1 over a, or you could divide by it, but you're going to get 1 over a times y equals x squared. We're going to rearrange the x squared. We're going to put it on the left, and we're going to give you a new value now, and we're going to teach you that 1 over a is equal to 4p. It's just a new value, new formula, and we're going to cover that. So in a standard parabola with a vertex of 0, 0, x squared is going to equal 4p times y. Now remember that the p is the length between the vertex and the focus, or the length between the vertex and the directrix. And again, we'll talk about more of that later. Okay, so for right now, that's how this kind of formula goes. Now, let's say that we didn't have a vertex at 0, 0. This would look a little bit different, right? If we didn't have a vertex at 0, 0, we would keep the h and the k in there, and we'd still rearrange it. So we would move the k over, subtract k from both sides, right? We would multiply by 1 over a on both sides, 1 over a, right? And we would get 1 over a times y minus k equals x minus h squared. And again, we want the squared part to be on the left side. So I would rewrite it a little bit, and it would be x minus h squared equals 1 over a times y minus k. And again, remember that 1 over a equals 4p. So it would be x minus h squared equals 4p times y minus k. So all I'm really doing is rearranging the original formula for a parabola, right? That opens up or down where the x is squared. I'm just rearranging it, and I'm swapping out 1 over a for 4p. And so again, this is sort of how this would look. Now notice that these are all parabolas where the x is squared. Well, parabolas where x is squared, they open, and I would venture to say I'll write it like this, ax squared. They open up if a is positive, and they open down if a is negative. And you learn that. Well, we also have parabolas that go sideways, and those would look more like this. X equals y squared, like that, or x equals a times y squared. And again, if a is positive, it opens to the right, okay? If a is positive, let me kind of make that a little bit neater. And if it's a is negative, it opens to the left. Now these are not functions, because remember, if I do a straight line test, I'm going to hit 2 points. So these are not functions, but they're still valid parabolas. And so we are also going to deal with the scenario where you have a y squared equals 4px. So once again, we would start out, right, where we would say x equals a times y squared. Then we would multiply both sides by 1 over a. We'd get 1 over ax equals y squared. And remember, we want the squared part on the left, 1 over ax. And again, we know that 1 over a is 4p. And so again, we end up with this. So once again, I'm just kind of describing how this kind of happens. How do we get this 4px? But again, remember, this is your parabola that goes up or down. And these are your parabolas that go to the right or to the left. And now, again, we'll really go into detail on how to do it. It sounds much more difficult than it is. So when I come to this problem, first of all, I'm going to notice that it's an x squared. And I know that this is 1 over a, or it's my 4p. So I know that my a is positive. So a is positive, which means my graph is going to open like this. So I have the general idea of what my graph is going to look like. I know that this value, 4p, equals that 8. So I know that p is 2. So I know that p is 2, and I know that my graph is a parabola with center at the or the vertex at the origin, 0, 0. And so I know that because I know it opens upward, I know exactly where my focus is going to be located in my directrix. Now, I do have to have some accuracy in my graph. And so what I like to do is do a table of values. Basically, I'm just going to pick one value. And I like to plug in whatever the squared part is. So for example, if x is 1, then it's going to be 1 squared equals 8y, which means that I know y is going to equal 1/8. So if x is positive 1, y is 1/8. So if this is 1 and this is 1, I know it's going to be like here. So it's going to be very fat. And I know that my graph is going to mirror So I know it's going to also be negative 1/8. And that's really all I need to do. You don't have to be super accurate with the appearance. These fractions are hard to graph, but just kind of write the, somewhere let me know that that's what that is. Okay, so now that I have a general idea of what the whole graph looks like, the parabola looks like, now what I can do is I can now find my focus and my directrix because I know my P is 2. So I know I have to go 2 units up for my focus. So my focus is going to be this point right here. So remember, focus is always inside the parabola. So it's going to be located at 0, 2. And I know my directrix is going to be 2 units down. So my directrix is going to be this line that goes through negative 2. So that's my directrix. And there's my focus, here's my p-value and my vertex, and there's my graph. So that's how we're going to go about doing this. So again, we come to the next problem. Notice this is a y-squared graph. So I know this is going to go this way if a is positive, and it's going to go this way if a is negative. And in this problem, a is negative, so it's going to be this one. Again, I know my center or my vertex is going to be located at 0, 0. So my vertex is here. Actually, let me do it in red. So my vertex is going to be there. And now I know that 4p equals negative 28, which means p equals negative 7. I know it says negative 7. Don't worry about the negative because remember, p is really a distance. So it's kind of the absolute value. So negative 7 is fine. Just know you're going to go 7 in one direction for the focus and 7 in another for the directrix. And that's going to be from the center. So again, I just need to know which way my graph is going to open. So again, I'm going to get a little table and I'm going to pick one value here and I'm going to plug it in for here. So I'm going to make y equal to 1. So 1 squared equals negative 28x. 1 equals negative 28x, and I know that x is negative 1 over 28. So I know that one point on my graph, x, here's negative 1. 1/28 is going to be barely anywhere, right? Here's 1. So I know at negative 1/28, it's going to go this way. So I know my graph is going to look like that. And then I know if I go 1 down, it's going to mirror. These y-squared graphs are weird because remember the axis of symmetry is now in here. The axis of symmetry goes through the vertex horizontally. So the graph mirrors up and down. It's different than what we've done before. So again, there's my graph. So I've done the first part. Now it wants me to find the focus. Well, I know the focus is inside the parabola. And so if my center is located at 0, 0, my p-value is 7, I'm going to go 7 units to the left. So 1, 2, 3, 4, 5, 6, 7, right? I know it's a terrible drawing there, but I'm going to get to a point right here, which is going to be negative 7, 0. And that's going to be my focus. And I know my directrix is going to go 7 in the other direction. 1, 2, 3, 4, 5, 6, 7, right? So that's going to take me to 0.7, but basically remember it's a line. So it's going to be this vertical line that goes through it at x equals 7. So my directrix is x equals 7. My focus is this point here at negative 7, 0. So remember, your directrix is always the equation of a line. Your focus is an ordered pair. And that's going to be all you need for this problem. So again, we keep going here to these problems we're going to do. Now again, you have to get your x squared isolated. So I'm going to start out by moving everything over. So I'm going to start out by x squared equals 1 over 4y, like that. And remember that it's an x squared, so it's a parabola. 1/4 is positive. The a value is the a value is really here. This is 1 over a, but again, it's positive, and so this is a graph that's going to go up. Now, again, how far? Let me just kind of get. I know my vertex is 0, 0 here, and again, I'm going to just pick a value, so I'm going to make x equal to 1. So it's going to be 4 times 1 squared equals y. That's 4 times 1 equals y. So 4 equals y. So when x is 1, y is 4. So again, my center's at 0, 0. I got 1, 1, 2, 3, 4. And my graph will look like that. And again, it's going to mirror. So it'll look something like that. So my graph looks good. Now that I have my graph, I need to find my foci or my focus and my directrix. And again, I'm going to need my p-value for that. So I know that in this original problem, I know my p-value is going to be 4p equals that quarter. So I have to times by 1/4, times by 1/4, and I see that p is going to equal 1/16. So I know that my directrix and my focus are going to be 1/16 units away from my center. So let's just say this is 1/16. So this is going to be 0 and 1/16. And I know my directrix is going to be 1/16 down. So my line is going to be this horizontal line through y equals negative 1/16. So that's my directrix and that's my focus. And again, I don't expect your drawing to be to scale because it's just too difficult. But that's going to be the answer. So again, we graphed it. We have the graph with accuracy. We have our center correctly. We have our focus and we have our directrix. So again, now we go to the next problem. And as we mentioned before, we want the y squared or the x squared isolated. So it's going to be 1 over 8x. I know this is going to be a horizontal graph and it's going to open to the right because a is positive. Okay. So my center, my vertex rather, is still 0, 0. I'm going to find my p-value. Remember, 4p equals 1/8. So that means p equals 1/32. So my p-value is really weird. Again, my center is at 0, 0. Let me find an accurate value. So I'm going to plug in 1 for y, and I'm going to get 8 times 1 squared equals x. So that's 8 times 1, or 8 equals x. So I know if I go to 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, I have a point. And I know then that I have to go down to negative 1 and it's going to be symmetrical. And so there's my parabola. Now I need to figure out where my focus and my directrix will be located. And when the center is 0, 0, it's super easy. I know my focus is going to be inside the parabola, so it's going to be to the right. So it's going to be, let's say, right here. And again, the ordered pair is going to be x is right, because the center, let's think of it that way. Remember that the center is at 0, 0, right? 0, 0, or the vertex is at 0, 0. I know my x value is going to, I'm going to have to add 1/32 to the x, but the y is going to stay the same. So I know my focus is located at 1/32 and 0. I know my directrix, I'm going to have to go back 1. So again, my directrix is going to be the line of, it's going to be x equals, and it's going to be the 0 where it's located minus 1/32, or just negative 1/32. So again, that's going to be, let's say here, and it's going to be the line of x equals negative 1/32. So again, I know it looks weird. It's, kind of hard to do these numbers, but that's going to be your answer. All right, so now what happens when we have h and k that's not 0, 0, right? Well, again, remember we sort of already talked about that. You're going to have, if it's an x squared, meaning an up or a down parabola, then you're going to have the x minus h squared on the left. On the right, you're going to have the 4p y minus k part of it. The only thing squared is the part that contains x. If you have the y being squared, remember that's your side-to-side parabola, horizontal parabola. And again, on the other side, you're going to have x minus h with the 4p, but it's not going to be squared. So again, we'll keep going here and do some examples. So here we notice it's an x minus 3 squared. So again, because the x is what's being squared, our parabola goes either up or it's going to open down. And because this is positive, I know it's going to be upward facing parabola. So I know my center, or I don't know why I keep saying the center, my vertex is going to be at 3, negative 2. Because this is x minus h squared, and this is 4y minus k squared, notice both of these are going to be the opposite signs of what you see. So it's going to be the opposite of negative, the minus 3 is plus 3, the opposite of plus 2 is minus 2. So our vertex is 3, negative 2. So 1, 2, 3, 1, 2. Here's my vertex, okay? I do it in red. Okay, so now I know where my vertex is. I still need to find my p-value. So remember that 4p equals 4. That means p equals 1. So I know that my focus is going to be 1 unit away from the vertex, and my directrix will be 1 unit away in the other direction. But my graph has to be somewhat accurate, so I am going to have to come up with an x and a y value. So I like it when whatever's being squared here equals 1. So I notice that if I make x equal to 4, I'm going to get 4 minus 3 squared equals 4 times y plus 2. This is going to be 1 squared, or 1, and this is going to be 4y plus 8. I'll subtract 8 from both sides, and then I'll divide by 4, and I'll get y equals negative 7/4. So negative 7/4 is equivalent to negative 1 3/4. So I know that when x is 4, right there, right, y is negative 1 3/4, which is a little bigger than 2. So it's going to be about here. And I know on the other side it'll mirror. And so my graph looks something like that. Again, it doesn't have to be perfect. As long as I know that those ordered pairs came from actual computation, okay? Now I need to find my focus and my directrix. So I know my focus is going to be 1 unit above this center here. So this point right here is my focus. And if my vertex is at 3, negative 2, and it's moving up, it's going to be located at 3 and then minus 2 plus 1 unit, which is 3 minus 1. So there's my focus. I can count or I can calculate, but either way, I know that my y is going to increase by 1. And for my directrix is going to be down 1, so it's going to be the line through y equals negative 3. So my directrix is y equals negative 3. So again, be careful with those equations of those lines, but that's how you do it. Again, we keep going to the number 6. Again, it's an x squared. I know we need the x part isolated, the squared part isolated. So I know this is going to be negative 1/4 y minus 2. So I know being an x squared, it's going to open up or it's going to open down. But because I've got negative 1/4 here, my a really is negative 4. My 1 over a is negative 1/4. Either way, I know it's going to open down. Okay. So I find my p-value, my 4p equals negative 1/4. So p equals negative 1/16. Okay, and I know that my vertex is located at negative 3, positive 2. So 1, 2, 3, 1, 2. So my vertex is here. And my graph opens down. I'm going to just plug in a value here. Again, when I do that, I'm going to think of a value that would make this equal to 1. So I'm going to do negative 2. So if x is negative 2, this is positive 1 squared, which is 1. 1 times negative 4 is negative 4. And I'm going to get negative 4 equals y minus 2. And if I add 2 to both sides, I get negative 2 equals y. So I know that negative 2 is a point. So negative 2, negative 2. And then if I go 1 unit to the left of it, then negative 4, negative 2 is the mirror image. And so my graph opens down, and that makes sense. So there's my graph. Now I need to use my vertex and my p-value to come up with my focus and my directrix. So I know again that my focus is going to be 1/16 unit below whatever this point is. So this point right here is -3, +2. That's my vertex. So I know that my focus is going to be -3, 2 minus 1/16. Okay, so 2 is 16, or no, 2 is 32 over 16 minus 1/16 is 31 over 16. So my focus is -3 and 31 over 16. Okay, so it's right here. And that's the ordered pair that would go with it. Let me kind of erase this. So I'm kind of erasing it because it can get kind of messy. But I know that my focus is always inside the parabola, and it's going to be 1/16 unit below that vertex. And my directrix is going to be 1/16 above it. So I'm going to go up 1/16, and here I'm going to go down 1/16, if that makes any sense. So again, for my directrix, right, it's going to be this line that goes through this, which is going to be y equals, and it's going to be the vertex is at y equals 2, and it's going to be 1/16 higher. So it's going to be 2 and 1/16, or 33 over 16. So y equals 33 over 16 is going to be my formula or my equation for my directrix. So again, I know it can get a little bit messy with all the work and the fractions and all that. Definitely probably want to work a little bit on the side for all these. And then the last one here. So notice here we have a y squared. Okay, so again, this is going to be a parabola that either opens to the right or opens to the left. And because this is positive, it's going to open to the right. Okay, so I know the way it's going to go. I know I'm going to come up with a little x and y value. Let me just do that. And I know that I like to make the side that's being squared. I like to work with that side, so I'm going to make y equal to 3. 3 minus 2 is 1, and I'm going to get 1 squared, which is 1, equals 24 times x minus 3. I can even divide by 24 here. And I'm going to get 1 over 24 equals x minus 3. I'm going to add 3 to both sides. And I'm going to get 3 and 1/24 equals x. So 3 and 1/24. So again, that's going to be 1 point. Now my vertex here is going to be, remember, it's always h and k, right? The h goes with x, so it's going to be 3. The k goes with the y, so it's going to be 2. So my vertex is going to be 1, 2, 3, and +2. So my vertex is right here. My graph is going to open to the right, and I know that when x is 3 and 1/24, my y value is 3. So 3 and 1/24, let's make it right there. And so my y value is going to be 3. So it looks like that. And so when I get 1 unit below, remember this is kind of like my axis of symmetry. So I'm going to have, when x is 3 and 1/24, I'm also going to have a y value of 1 there. And so there's my basic graph. So that checks off the need for the graph, right? Now I need to find my focus and my directrix, which again is going to involve the p-value. So I know that 4p equals 24, so p equals 6. And so I know that my focus is going to be 6 units in this direction, right? And it's going, my directrix is going to be 6 units in the other direction, right? So how do I do that mathematically? Well, let's kind of take our time with that, right? So I know that my vertex right now is located at 3, 2. And I know that, again, I'm going to go 6 units over this way. And so what I'm doing is I'm adding 6 units to the x. So I know that my focus is going to be 9, 2. So if I go over here, kind of extend this here to 9, I know my focus is going to be at 9, 2. because again, it's 6 units, 4, 5, 6, 7, 8, 9, 6 units over. Okay, again, 6. It's plus 6 in this direction. Okay, and then my directrix, I'm going to go back 6 units. So my directrix is the line of y equals, and it's basically the x I started with minus 6 units, or negative 3. So it's not the line of y equals, it's the line of x equals, because I'm changing my x, right? So x equals negative 3. And so that's my directrix. So I come over to here to negative 3, and I know that this is going to be my directrix. X equals negative 3. So here's my focus, and this is my directrix. And you're done. That's it. So my directrix is this. So just be very, very careful. Take your time. Understand the direction in which your graph goes. The direction matters because remember that the focus lies within it and the directrix lies outside of it. So if your graph opens up, your focus is here, your directrix is here, right? This is P and this is P. There's your vertex, right? If your graph opens downward, right, your focus is here, your directrix is out here, okay? There's your vertex. And again, the distance is P. So you always have to know the proper direction in which your graph grows, or else you're going to confuse your focus and your directrix.